So you see here, this should be clear to you. You have your source resistance Rs, you have your drain resistance Rd, and you have the capacitance between drain and substrate CDS. You have the capacitance between gate and source CGS. You have the capacitance between gate and drain CGD. You have one more parasitic capacitance called CGDP and CGSP, which is going to be the parasitic or overlap capacitance. And as usual, you will have the current source GM into V dash GS. Okay, so this is the same as JFET. You have the circuit, except you have two additional capacitance called as parasitic or overlap capacitance. These are there because of the interaction of the already existing capacitance between the source and drain terminals. Okay. So in the real-time devices, the gate oxide will overlap the source and drain because of toleration of fabrication factors. So the drain overlap capacitance will lower the frequency response of the device. So among the two parasitic capacitance, CGDP and CGSP, what they have found is the CGDP will lower the frequency response of the device, and the parameter CTS is the drain to substrate junction capacitance, and other resistances are known to you. The small signals current is controlled by the gate source voltage to the transconductance. So among all the parameters, what they say, the CGDP is very, very important because it controls the frequency response of your device. So it controls the frequency response of your device because it is present at the output terminal and the gate. Gate is where you give the input voltage to operate the device, and drain is where you measure the drain current. So this capacitance between G and D acting as a parasitic capacitance will reduce the frequency response of your device. Parasitic, the meaning of the word parasitic is it cannot act independently. It can act only with the already existing capacitance. So CGD and CGDP will act together. CGS and CGSP will act together. Parasite means it needs some other help from some other thing, right? So same thing here, this capacitance CGDP and CGSP cannot act individually, and they need the help of CGS and CGD for their functioning. And among these two parasitic capacitance, from the experiments, they found out that the CGDP is going to be playing a crucial role in reducing the frequency response of your device. Other resistances and capacitance, what you see in the diagram, will have their usual significance. So this is the small signal equivalent circuit. So you can see here gate, and you have capacitance CGST and CGDT. I think the CGST and CGDT or the, when capacitance is in parallel, you can add, correct? So I am going to club these two and put it as a single capacitance, and I'm going to club these two and I'm going to put a single capacitance. That is going to be CGS capital T and CGD capital T. Okay, so CGS capital T, CGD capital T. You have this current source, you have this RDS drain resistance, you have the capacitance between the drain and substrate, and you have the drain resistance, you have the source resistance. So this is going to be the equivalent circuit. As we have seen, we will not have three pairs of resistance and capacitance as we have seen in JFET, because the construction is metal, oxide, and semiconductor layer in MOSFET, right? So you will have only capacitance between the three terminals, and you will not have resistance here and the resistance here. So those two are the difference between your JFET and MOSFET, small signal equivalent circuit. See, while reading this, you should compare the diagram and study for JFET and MOSFET. You should not read blindly. So only when you compare and study the different small signal equivalent circuit between JFET and MOSFET, you will clearly understand which component is missing, why that component is missing in MOSFET, which is present in JFET. What is the reason for that? You would be able to understand everything very, very easily. Okay, so when you compare this small signal equivalent circuit of MOSFET along with the small signal equivalent circuit of JFET, you can clearly understand here you have so many components, but here it is completely reduced because the construction of MOSFET itself is completely different from the construction of JFET.